Find the intervals of increase and decrease and relative extrema if any of the given function f of x equals to x to the 1/3 times x plus 4. Rewriting the given function by distributing the product, we obtain f of x equals to x to the 4/3 plus 4 times x to the 1/3. Taking the derivative, f prime of x, we obtain 4/3 x to the 4/3 minus 1, which is 1/3, plus 4 times 1/3 times x to the 1/3 minus 1, which is negative 2/3. Taking a common factor of 4/3 and x to the smallest exponent, which is negative 2/3, we obtain f prime of x equals to 4/3 x to the negative 2/3 times x plus 1, which is equal to 4 times x plus 1 divided by 3 times x to the 2/3. Critical points are at x equals to negative 1, where f prime of x is 0, and at x equals to 0, where the derivative fails to exist, meaning the function f of x is not differentiable at x equals to 0. Construct a sign diagram with the critical points negative 1 and 0. Pick test points in each of the intervals created by the critical points. Pick negative 8, negative 1/8, and 1 on each of the intervals. Find the sign of the derivative at each of the test points. F prime of negative 8 is equal to 4/3 negative 8 plus 1 divided by negative 8 to the power 2/3, which is equal to 4/3 times negative 7 divided by negative 2 cubed to the power 2/3, which is equal to 4/3 times negative 7 divided by 4, which is negative 7 over 3, a negative number, meaning the function is decreasing in the interval containing the test point negative 8. Similarly, find f prime of negative 1/8, which is equal to 4/3 negative 1/8 plus 1 divided by negative 1/8 to the power 2/3, which equals 4/3 times 7/8 divided by negative half cube to the power 2/3, which is equal to 4/3 times 7/8 times 4, which equals 14 over 3, a positive number, meaning the function is increasing in the interval containing the test point negative 1/8. F prime of 1 is equal to 4/3 times 2 divided by 1, which is 8 over 3, a positive number, meaning the function is increasing in the interval containing the test point 1. The function, therefore, is decreasing in the interval negative infinity to negative 1, including negative 1, increasing in the closed interval negative 1, 0, and increasing on the interval 0 to infinity, including 0. Combining the two intervals, we can say the function is increasing on the interval negative 1 to infinity, including negative 1. as the function is continuous at x equals to 0 and at x equals to -1. The sign of the derivative changes from negative to positive at x equals to -1, meaning there is a relative minimum at x equals to -1, and the value of the function at x equals to -1 is equal to -1 to the 1/3 times -1 plus 4, which equals to -1 times 3 equals to -3, as shown here. As the sign of the derivative is positive on either side of the critical point x equals to 0, the function is increasing throughout from -1 to infinity.